Till now we have seen that graphically we are able to find speed from distance time graph, velocity from displacement time graph. Here we are looking at the possibility of finding displacement from a velocity time graph. So is this possible? The answer is yes. What is the procedure? Well, it is to find the area under the graph. What does this mean? I have done one previous problem, one problem somewhere along the line. From there you can begin with, and here too we'll be looking at this practically. We'll be taking up a problem and we will be finding out the displacement from that graph. So how does this work? What is the logic behind this? See, area under the graph is nothing but, this is the velocity time graph, this is your graph, right? So area under this graph, say line ABC, is nothing but set of lines which is perpendicular to the x-axis. You can do this, and the area bounded between this region, right, this space, this is your area under the graph. So this is A, B, C, D, E and F. So this space is known as area under the graph. So you can find the area under this by finding the area of the rectangle, this particular rectangle, and the area of 1, 2 and 3, two rectangles and a triangle. So basically we'll be able to make use of L into B by 2, if not combination of this two. And we will be using velocity into time. So this set of formulas we will be using to find the area under the graph. Again, we're still not at answer how it works. I'll be talking about it. So let's find the area under the graph. Like for this example over here. So I have to find the area under the graph. So the graph being from A to C. So this is basically moving. I'll show you where exactly. From 0 to 8. And exactly at 5, there is change in velocity. Okay, just this is for extra information. So basically you have this region. Okay, so we have region 1, 2 and 3. So we have to find this region. How do you do this? Region 1 is nothing but area of a triangle. Area of region 1 is nothing but half into base into height. So what is the base over here? It is still 5. So this is velocity time graph. The time is along the x-axis. So this is 5 minus 0 seconds. I'm writing the unit so that you guys understand what you're finding. So this is time, right? The base is time. So it is in seconds. You can see clearly over here. It is in seconds. And then the height over here is from 10 to 60. So this would be 60 minus 10. And this is velocity. So this will be in meter per second. So first is we'll find the numerical value, half into 5 into 50. And the units are seconds, and seconds gets cancelled, and you have meter. So meter is nothing but your length, is it not? So basically you're finding displacement. So area under the graph in a velocity time graph is giving you displacement. Okay, so this is the logic. Let's continue over here. 25 into 5 is 125 meters. Next, let's find the area of region 2. Do I have space? I kind of do have. Area in region 2 will be L into B. So this is 5 into height is 10. 5 into 10 is 50 meter. Again, same logic. Here seconds and meter per second will get multiplied. And because we have seconds common in numerator and denominator, they get cancelled, and we have meter. And we have area under the region 3. So here the length is 8 minus 5, and the height is 60 minus 0, that is 60. So this will be 3 into 60, that is 180 meters. So the total area is equal to this would be 355 meters. So this is your answer, right? So the total distance traveled by this particular vehicle from A to C with this time frame 0 to 8 seconds with this velocity, with all of these velocities, is 355 meters. So let me verify this. Remember, we are taking a linear motion. So motion in one straight line. Remember that. Keep that in mind. So we have 1, 2, 3, 4, 5 with increasing velocity, and then same velocity for next 3 seconds. And now I'm going to terminate the procedure. On cancellation, I'll get the graph. So what is the time over here? 8, and this is a distance time graph. At 8 seconds, the distance is around 350 plus. So if you want the exact answer, you need to decrease this, and at the corner you will be able to find that. Let me show it to you guys. Right over here, you'll be able to see the coordinate of the graph. Can you see that? So this is around 355. Can you see that? And the time is around 8 seconds. Okay, x and y value are able to see clearly. So that is 8 seconds. And we have 355. What is the answer we found? 355. You got it? So we got the exact answer. That's all. That's how you find it. So the logic is here, since we are multiplying velocity and time by finding the area, we are multiplying velocity and time basically overall. So velocity into time, what does it give? Displacement. So this is the whole funda. Okay, so displacement is a product of velocity and time, and we have area under the curve. We can find it using the formulas length into breadth and length into breadth into half and all of this. Okay, we'll do a few more problems. You will get quite a few problems. So understand, actually there's nothing much to understand. Basically everywhere just to find the area of triangle and rectangle, if not trapezium. If you're comfortable with finding the area of a trapezium, you can use that formula. So this is your concept, finding displacement from velocity time graph. The same thing is applicable for distance from speed time graph.